Okay, so this should be up front. This should be review from Friday. I understand if you don't quite remember it. It's been over the weekend. So the growth rate, guys, quiet down. The growth rate, remember, tells us how many individuals will be added per every one individual, okay? It's not written as a percentage, it's just written as a decimal. In order to figure it out, we just have to take 500 times the growth rate, and that'll tell us how many individuals will be added to the population. So with this, remember 0.1, just move the decimal place over 1, so we would get 50, okay? So that's how many would be added. So what would my total population be if I added 50? 550. So that would be after 1 year, okay, individuals. Now, if I have 550 now that I start with, I would have to multiply that by 0.1 in order to get the number of individuals that will be added during that second year. So 550 times 0.1 is 55 individuals. If I add that to what I started with, we end up getting 605 individuals for the second year. Okay, so we're just multiplying the growth rate to figure out how many individuals will be added. Now remember, to calculate the growth rate, it's the difference divided by the original. It's that same equation for a percent increase or decrease, but we're just not making it a percent, so we're not multiplying it by 100. So difference over original. Reason I keep hammering this into your head is because you need to know it. There will be at least one question on every AP exam that I've seen. There's at least one question that has you calculate percent increase. So the difference here, 750 minus 500 is 250. Over the original is 500. So what would my answer be? 250 out of 500 is half, so that would be 0.5 would be my growth rate. Okay. So we've been talking about density-dependent, independent factors, what limits populations. Who can tell me what is an example of an R-selected species? Anyone remember what R stands for? Reproduction, right? So which types of species would have fast reproduction? Flies, fruit flies. Yep. Mosquitoes, lots of insects. Okay. K-selected species have longer lifespans. They typically only produce 1 or 2 young. They have a lot of parental care or parental investment. So it would be something like a whale or an elephant or a human. Okay. We've also talked about density-dependent and independent factors. Who can give me an example of an density-independent factor? Weather, climate, temperature, those would all be independent. Density-dependent factors, food, space, competition, disease, those could all be examples, okay? We talked about the difference between populations, communities, and ecosystems, all right? A population is made up of what? If I have a population of humans, it's all humans, right? So it's only one species, okay? A community is all the living things in an area. So for example, like all the plants and animals and insects, all of that, okay? And then an ecosystem is all the living and non-living things in an area. We talked about, okay, exponential growth. What did we learn about with exponential growth? What shape is the graph? It's like a J that goes up, right? And we know that the population growth rate is increasing faster and faster with exponential growth. So with exponential growth, the rate of any graph is equal to the slope, right? So if we look at the slope here, it's pretty level, and it gets steeper and steeper and steeper. So that growth gets higher and higher and higher and faster and faster and faster. So with exponential growth, we get that growth happening quicker and quicker. We said that this shows an organism or a population at its biotic potential, right? Like its maximum potential that it can grow at. We also talked about intrinsic growth rate, right? This would show kind of like our intrinsic growth rate, our growth rate that's naturally in that population if we didn't have any competition or any limiting resources. Okay, so biotic potential and intrinsic growth rate are kind of similar terms. They're showing you what would happen if we weren't limiting our population by anything. Okay, but instead we said we get typically logistic growth curve. Right? What does a logistic graph look like? What shape? Okay, so that S shape, and it represents that carrying capacity. Carrying capacity is the maximum organism the population or an environment can support. Okay, so that's kind of a review of some of the terms we've been talking about. Your multiple choice is due on Wednesday, so make sure you get that to me. You might have some time to work at the end of class. For now, I need you to get out your notes packet. We're going to take a small amount of notes, and then we will be doing a lab. You guys will be bears. You'll get to go collect food. It'll be great. So we left off with survivorship curves, right? We still have to do those? That's where we left off? Okay, perfect. So survivorship curves, you guys looked at this a little bit in the graph when I was gone last Thursday. Survivorship curves show us when individuals are going to experience high mortality and when they are going to experience low mortality or low death rates. Okay, so what I need you to do in this box, I just need you to draw me the lines. In your note packet, you don't need to draw out my last class thought you have to draw the animals. You don't need to draw the animals, just the lines. Now these are actually, it seems like, oh, well these are so lame, type 1, type 2, type 3, kind of lame names, and they're hard to figure out which one is which, but it's actually pretty easy if you memorize them going down. Type 1 is at the top, type 2, type 3. So just picture drawing those in your head. 1 is at the top, and then it just goes down, 2 and then 3. So let's write some examples of those species. And so that for type 1, we would get, right, so like whales, humans. If you didn't write the case selection here, you might want to write case selected down here. Type 2, they're going to have an equal chance of death throughout their lifetime. These would be things like birds. Birds typically have an equal amount or equal chance of dying. Now, if they're young, they probably have a little bit more chance of dying than when they're old. But birds, things like squirrels, well, we know squirrels are not the smartest, and, well, a lot of them end up those road farms. So squirrels, also insects. An insect, it doesn't really matter when it's, it'll probably die at any given point in its life. And then type
I got another one.
So plants are typically type 2 is the best example for that. So survivorship curve. Okay, the common organism survives better. Now they probably don't plan this, but what ends up happening is those populations live close enough that individuals actually migrate from one population to another relatively easily. And when they migrate from one population to another, they bring their genes with them. So they're connected. It's like a whole bunch of our population is going to be. So metapopulation, we talked about habitat corridors, right? Different things connecting those populations so that they can have, even if our habitat gets fragmented, they can have those ways to get from one population. Want these populations to be connected is because if they're not connected and we get a population that only has a few genes in it, like a panther, So if you don't remember too much about genetics, totally fine, but basically remember they each have two alleles or two genes, right? Two versions. So that's in a population. So now we're going to switch to and what we end up seeing is that those species will kind of develop different niches around that research. So maybe is an organism that feeds off of another organism, but it does not kill it. It is different than predation. And then mutualism, both of the species benefit. So here, parasitism, things like they both end up benefiting. Okay, so we'll talk about some examples. For example, here we've got so both of the species end up benefiting. We'll go through examples tomorrow. Commensalism, one species benefits, and there is no effect on the other species, is the last one we'll do. So here we have like everyone good? All right, so what I want you to do, look at that table, see if you can fill it in. Your options are pluses, minuses. So check your answers. Competition is minus minus. Sometimes people think, oh, well, it's plus and minus because one species gets the food. But what if they're getting habitat? So they might benefit. And commensalism, plus and, which is 0. So the very last thing I need you to write down, I did not put on your sheet, so you can either, there's two spaces you can write it. You can either write it at the top, write about commensalism, or if you want to go on the previous page underneath number 5, there's space there, it's not very long. Symbiosis just means living in close association. Ready, set, go!